Next, I want to talk about the least squares estimation in R. We have seen that the least squares method, basically what it does is find the parameter estimates that we get here, the y-intercept, the slope for square footage, and the slope for house age, that minimize the value for SSE. So to do that, those least squares estimates are obtained using the LM function, which stands for linear model. You're going to use the market value in thousands as your Y, square footage plus house age, to determine the basically the relationship between the two predictors and the response. And then I'm going to get the summary to just show you that relationship. So I'm going to run that. And you can see a few things. The estimates here, 197 for the y-intercept. What that means generally is if we have a house with 0 square feet and the house age is 0 years, then we estimate the price of the home. And because we chose the values in thousands, this is $197,000. Now, this is not informative. It might not mean exactly something that can happen in real life, because a house of 0 square feet and just 0 age, I mean new home, basically that doesn't might not be something realistic. But nonetheless, this is the interpretation that we get. These parameter estimates, we can call it y hat or estimated market value, because it's an estimation. It's not really what will happen. Generally will be off of that number. And so this, we call it beta hats because these are estimates again. X1, if we represent square footage as X1, or for example, house age as X2, you might see this equation like this just to make it shorter, but you can also write it like this. Just make sure to write that this is an estimated value. Okay, so we saw the relationships that are linear relationships that we have here with square feet and market value and house age and market value. But when we see here square footage has a positive relationship and house age has a negative relationship, that doesn't make too much sense because we can see the house age is not necessarily negatively related. There's a positive slope here, but you have to count that now this is the joint relationship of the variables. And what I mean with joint is that there is a partial effect of the variable holding the other constant, and that's what we mean when we have a multiple linear regression. In this plane, you can better see this joint relationship because we have only two predictors. We are able to visualize this. And unfortunately, we can't do this when we have more than two predictors. But you can see that the plane goes up. I mean, it's positively as square footage goes up, but then it tilts a little bit down with house age. And that's what happens when you have that's what happens here with this estimation, and that's why it's giving you this slightly negative slope. Okay, so note that we can only plot this in 3D because we have two predictors, but more than that, it's not going to be possible to do. If you want to get this graph in R, you can do this in RStudio by installing this RGL package and the card package, and we'll go about installing. If you want to know more, let me know. But you would just use install.packages function and install RGL and car, and then you can just use this function here. This does not work in Google Colab, as this is more a feature that you can get when you're using RStudio in your computers. But something else to know is that this RGL package sometimes has issues installing in Mac machines. So just be aware of that. So interpretation, we have talked about this estimation of the y-intercept, but for the slope, it's important to mention that this is the estimated increase in market value, that $40 for home, as for each 1 square foot increase in the size of the home, but you have to hold or compare to houses of the same age. The same with the increase in 1 year. The house goes down by 825 when comparing homes of the same size. And that's what we mean when we say partial regression coefficients, because we have to interpret these for constant values of the other homes. And this might make more sense to you now when you have this estimation. If you keep the house of the same size, but you increase the age by 1 year, then that basically means is related to a decrease in the value of the home by 825. The same thing with the square footage. Comparing to houses of the same age, if you increase the square footage by 1 foot, then it increases the price by $40.